Hi, my name is Anastasia Goulopoulos. Today I'm going to be talking about how we converted oxygen probe data that was implanted within the muscle of elephant seals into an oxygen saturation profile. We did this for two reasons. One was to study the anthropological effect of humans in the ocean and how that affects the diving nature and the hypoxic events that elephant seals and other aquatic mammals undergo. The reason for this overlap is because the noise pollution that is caused is similar to the sounds that they hear from predators, and it causes them to dive deeper and for longer periods of time. They're equipped to do this because they have specialized cardiovascular systems that allow them to not have oxygen for long periods of time. And by studying this system, we can hope to develop treatments for humans who undergo hypoxic events, since we are not as equipped to deal with those events. So we've already developed the probe. Basically, we used a photo-based probe. We send light through the muscle, and we then calculate how much of the light gets reflected back into the photodetector and use that information to find the oxygen saturation profile. What we did is we implanted the probe within seals and then allowed them to sleep in the lab, and we corresponded the probe data into these dips of oxygen that they face whenever they undergo sleep apnea, which is when you don't have oxygen for brief periods of time as you sleep. And we validated this results using audio plots, as we'll see later on. So this is basically Beers-Lambert law, just comparing the the analog probe data back into oxygen saturation data. And what we did is we averaged out the path length, or the path that each photon took from LED to detector, in order to get more accurate results. So here's the probe data. We see that the dips in the analog data correspond to dips in oxygen saturation. And the way we validated this or saw that this was actually tied to the sleep apnea events is that we used audio plots. And so as the elephant seals were inhaling and exhaling, or in between the periods of exhalation and then their next inhalation, they're not getting any oxygen. And so we corresponded those we saw that it was corresponded to areas of low oxygen saturation. And you see these dips here. And these are each of the different LED colors. So from this study, we saw that we were successful in implanting the oxygen probe. We saw that we were able to get oxygen saturation data from this probe, and then we validated it using audio plots. And just a brief thank you to everybody who worked on this project. Thank you.